Hey guys, so this is part 1 of graphing nonlinear functions. So make sure this is the first video that you're watching. But this week we are still graphing, but it's a little different because we are no longer graphing lines, we are graphing curves. And we have seen this earlier in the year briefly. Okay, so let's say, for example, we have y equals x squared. Now this is a parent function. And I'm going to throw in some buzzwords as we go through, and I'll elaborate more as we go through the week. But basically, this function, other functions can be built off of it. So when we're graphing curves, we have to actually plug in values to get our coordinates. And so we use a little t-chart to do so. And I hope some of this is coming back to you. I told you all earlier this year that I like to use a default domain, which is our x values. They're just really easy numbers to plug in, and it gives you a full picture of the graph. And so those numbers are -2, -1, 0, 1, and 2. Okay, and so what we're creating are coordinates. And so the first thing I'm going to do is plug in each of these x values into this equation so I can find my y values so that I can actually have coordinates to graph on my coordinate plane. And so if I plug in -2, -2 squared is -2 times -2, which is +4. -1 squared is -1 times -1, which is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So now I have actual ordered pairs here. Okay, that's what you're doing. You're actually graphing each one of these. And so that's what I'm going to do. So -2, +4. -2, +4. -1, -1, -1, -1, 0, 0, 1, 1, and then 2, 4. And if you'll remember, this made kind of like a U shape. And that's what that is going to look like. So we've created, and it's also something called a parabola. So there is another buzzword for you guys. Okay, now what we're going to look at next, and I'm going to color code some of this, is what happens when we change the parent function. And so we're transforming it by, we're going to have the same general shape, but it's just going to move a little bit. And so let's say, I'm going to use blue. Let's say that we have y equals x squared plus 1. Okay, so I'm still going to use the same domain here. I have -2, -1, 0, 1, and 2. But this time I'm going to plug it into this equation versus this one, and we're going to look at the actual difference. So if I plug this in, I would say -2 squared, which is 4, plus 1 is 5. -1 squared is 1, plus 1 is 2. 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. 2 squared is 4, plus 1 is 5. So now I'm going to graph these coordinates in blue so that you're able to see the difference between this function and this one right here. And so I have -2, +5. So -2, and then 1, 2, 3, 4, 5. Then I have -1, 2. So -1, then 1, 2. And then I have 0, 1. And then I have 1, 2. And then I have 2, 5. Do you notice here we have this same exact shape, and it just shifted upward 1. And so you can kind of think of that like we had our y-intercept before, because this was our parent function. It's not our slope, but it's the shape of our graph. And then we took that and we shifted it up exactly 1. So we're going to look at some graphs that have some relationships with one another and then work on plugging them in. So this is your first video. Stay tuned for your second video in just a moment.